All right, in this function, we actually have a product of two different composite functions. So there's actually four separate functions going on. So if I think about what to use, let's see, I have multiplication going on between these two functions. If I think about trying to cover up a piece, let's see, I could cover up this piece, and that would make this thing an outside function, and the blue an inside function, but I still have this other function over here, this being an outside function, and then its inside function being the 2x plus 1. So I actually have two separate chain rules that are being multiplied together, and the thing that encompasses the entire expression is the multiplication. So here we're going to need product rule and chain rule. And since our chain rule is kind of inside our product rule is the thing that encompasses the entire expression, that means we're going to start with the product rule. And then within our product rule, we'll be taking in derivatives inside the product rule, and that's where we're going to apply our chain rule. So we start with the product rule, and as a reminder, the product rule is if I have two functions multiplied together, to the derivative of them is taking the derivative of the first one times the second function plus the first function times the derivative of the second one. So that's our formula. So this will be our f and this will be our g. Both f and g are composite functions, so we'll have to apply the chain rule once we get those out. But we're going to start with that first line of just setting up the product rule. So that first sentence is get the product rule set up, and we're not even going to take the derivative in this line. We're just going to put in the terminology of where to take the derivative. So the first, following this formula here, I have the derivative of the first function. So that's the derivative of 2x plus 1 times the second function, which is x cubed. Oh, I'm sorry. You know what? I forgot my exponent of 5 right here. So I want to make sure I put brackets around that because I want to make sure I take the derivative of the whole f function, not just the inner one. So we have 2x plus 1 to the fifth. We're taking that's our f function. So and our g function is x cubed minus x plus 1 to the fourth. And then add, so now I'm doing this part, so that's just the f, so it means the function with no derivative, but don't forget the exponent. And then the derivative of the second function, which is, and remember we want to include that exponent, so I'm going to use parentheses inside of brackets so I can include that 4 in the derivative. All right, so you can see each of those derivatives. There's one derivative that we're going to take here, right? That's where our ddx is. And then the other derivative is over here. And both of those are composite functions. So both times you take a derivative, we're going to be applying the chain rule within the product rule. These two, this one and this one, we're not going to take the derivative. Those two are already done, so we're just going to copy them down. So now I'm going to do the chain rule. So, or the next step. So piece by piece. So the first thing I see is a ddx, which means I have some calculus to do. I got to take the derivative of this thing. That means chain rule. So my outside function is a power function, u to the fifth. So I put 5 out in front and make the exponent of 4. And the u is the 2x plus 1. That's the inside function. And then I got to do the derivative of the inside function. So that is this piece right here. That's the derivative of that. So it still has another level of derivative in it. And then the next piece, this piece doesn't need any kind of derivative. It doesn't need anything. It's just the function copied down. So it has to keep going. It goes along for the ride all the way until the end. That's got to be in that final answer, but it doesn't need to be, there's no more calculus that needs to be done to it. Same with this term. This is just copied down as is. And now I see a d dx. So that tells me, oh, I need to do this, the derivative of this guy. So I'll do that. So that's going to be a chain rule because it's a composite to the power, it's a power function to the power of 4. So I'll do chain rule. So 4 times my u to the third power. My u here is x cubed minus x plus 1. And then since it's the chain rule, I still have to multiply by the derivative of the inside, which is d dx of this, x cubed minus x plus 1. Now I have some copying to do. This doesn't have any ddx. Anything that doesn't have a ddx is just going to get copied down. The only things I have to do are the ddx. So I'm going to copy this part down. And once I see a ddx, I'm like, oh, I got some calculus to do, so I got to take the derivative of 2x plus 1. Well, that's 2. And then this part's already done, so I can just copy it down. This part is, I took the derivative already in the last step, so that one is black now. And my last derivative, I have another ddx, so that means I take the derivative of this guy. X cubed minus x becomes 3x squared minus 1. I don't see any more ddx's, so my calculus is done. Up to here, I was doing calculus, but now I'm not doing calculus anymore. No more derivatives to take. I'm just doing algebra now. So from here on out, I'm just simplifying it and trying to make it look pretty and cohesive. I do have like a plus sign between two big kind of ugly terms. Don't love that, so I would like to get rid of that plus sign somehow by factoring some stuff out and simplifying what we can. I'd like to bring all the coefficients in front if I can. I can't bring the 4, like this 4, I can't bring it in front right now because there's still a plus sign there. So I gotta kind of deal with that first. So one thing that happens with chain rule a lot is that we get these repeated polynomials. So I can take out a 2x plus 1. And so this is one term, and this is the second term. And I can see within one term I have 4 of those. And in the second term I have 5 of those. So that means I can take out 4 of these. And then I have this guy. I have 4 there and 3 here. So that means I can take out 3 of them. And I'll leave the coefficients in there for now. I'll just kind of get those the next step. So now I'm going to just kind of see what we have left. So after I take this out of that first term, what do I have left? I have a 5. I've already taken out all the 2x's plus 1s. I still have a 2. And I have 1 of these left. But the nice thing about having only 1 of those left is now I can distribute. The 5 and 2 will become 10, and I can distribute that into those parentheses so I can simplify stuff. And then we have in our second term, so plus sign, I took 4 of these, so I have 1 left. I took 3 of these, I have a 4 still. And I didn't take any of these, so I'll still have that guy. And then this is around big parentheses or a bracket because I still have that plus sign. But now notice here, there's no more exponents on polynomials, so I can simplify what's inside that the black writing there. So I'm just going to copy down the first 2 terms because those I've already factored out. I'm pretty satisfied with those. What can I do here though? Let's see, I can make 5 times 2 can be 10. Oh yeah, that's 10. And then I'll take that 10 and distribute it. So I'll get 10x cubed minus 10x plus 10. And then over here let's distribute the 4 first to this. So I get 8x plus 4. And then I can FOIL that with my 3x squared minus 1 on the next line. So a lot of this I'm just going to copy down. And I just want to get rid of those last parentheses so I can combine what I can and get just a row of 3 factors without, whoops, I'm going to FOIL this. So let's FOIL this. So I get 8x times 3x squared, so that's 24x cubed. And then 8x times negative 1, so minus 8x. And then 4 times 3 gives me 12x squared, and 4 times 1 gives me negative 4. And combining like terms here, I get 10 and 24 at 34x cubed. And then for x squared, I have a 12x squared. For x's, I have a negative 10 and a negative 8. And then my constants, 6 and 10 and negative 4, so that's 6. So that looks much better with just 3 factors. Usually when we have a linear factor, we like to bring it out in front, and we could factor out a 2 if we wanted to. So I could factor out a 2 out of this one and bring it out in front at the same time. So I get 17x cubed plus 6x squared minus 9x plus 3, and then times those original 2 factors. And there we go. There's our final answer.